This is the fundamentals of networks, so let's get started. First, a network consists of two or more connected computers that are able to exchange data with each other. The important part here is including two or more and exchanging data. For the ups and downs, since all computers are connected, users can go on any computer and log in. This is also known as hot desking. They can exchange data with other computers, like sending emails, can share hardware such as printers, can install updates on all computers at once. However, the downsides are that it's expensive to set up since more hardware is needed, it's vulnerable to hackers since malware can easily spread, and it may run slower if lots of data is travelling on the network. It's also difficult to manage so it requires specialists to maintain them. Key point here is including hiring specialists. On to PAN, LAN and WAN. Bluetooth is an example of PAN, so every time you listen to music, remember PAN. Obviously, as a result, it doesn't really have a large range, so we call this a small physical area which localized devices can connect to, or something like this will work in the exam. LAN is like our house Wi-Fi, so obviously then you would know that hopefully it covers a larger range than PAN, or what you need to say is a small geographical area. Also know that organizations or individuals own the infrastructure of the network. WAN, this is like the big daddy of all the networks. LAN covers small, WAN covers large. LAN infrastructure is owned by the organization or individuals. WAN rents the infrastructure, like telephone lines, to connect all those LANs together. As you can see, we've clearly labelled two differences and hopefully 4 more marks on your exam. On to wired and wireless. Wired would be fiber optic cables and copper. Differences between the two would be that obviously one's faster sending data since it has a direct connection. Wired's more secure because, well, let's imagine a hacker trying to break in and plug into the router to steal your data. That stuff doesn't really happen. Wireless would then be easier to access since it links back to the previous idea of plugging in. Devices are also more portable and wireless, massive tripping hazard if people started moving on wired. Now with topologies, there's two you need to know, star and bus. These are random names, when you look at it becomes obvious. Bus topology is literally a road, the bus cable and a bunch of stops, the computers. So anyone could look at that and think, well, bus. Star, same concept, it looks like a bloody star. If it gives you a picture and you still get it wrong, I'm going to smack you through the screen. Before we go drawing these yourself, let's define a network topology. It shows where the connections are made in a network. This will be the easiest mark of your life because the pictures do just that. Now on to drawing them. For bus topology you need a straight line and straight lines coming out of that straight line. At the end, make sure to put terminators. They're just small little circles, don't get frightened. The purpose of these is to prevent the signal bouncing back down the cable. Don't worry about the purpose, just draw it right and you're chilling. Start with the Hubble switch in the middle and draw lines coming out of it and put computers at the end. Should look like a star, obviously. For differences, bus is less reliable because the terminators could break or the main cable can break, which would lead to everyone on the network failing. However, on star, each computer has its own connection. Star is more expensive due to this, however. In terms of size, star is used for bigger networks and bus for smaller and cheaper setups. Star is more secure as data isn't being passed through the entire network to get to a certain computer, unlike bus. Bus is also more slower than star since all data that wants to be exchanged has to pass through one cable for all computers. Use the differences to determine which topology to draw. Moving on to the abomination we all hate remembering, protocols. Protocol is a set of rules to allow two or more computers to communicate, key points being set of rules and computers. An acronym to remember these names by is Teach Herbert Internet Protocols in seconds to understand everything fucking works. That's the best I could come up with for you. 2 is just a placeholder because otherwise this would have taken forever. Okay, so while it's good knowing how to remember it, it's equally good to know what they actually do. So Ethernet and Wi-Fi, while both separate, when describing we each use the same term. They're a family of protocols. Both carry data, but Ethernet through wired and Wi-Fi obviously wireless. If asked to compare, just use the wired versus wireless concept that we talked about before. For example, portability and ease of access. Hopefully you lot were actually listening. HTTP and HTTPS, when we visit websites this protocol is used. We see it in the web browser too, so there's no way you can really forget it. They're both used for web data transactions. HTTPS is more secure. The S isn't really there for no reason. It literally stands for secure. We use it for more sensitive information. It uses encryption. Make sure to say that, whereas HTTP doesn't. As you can see, I'm doing these in pairs, so please take the hint and remember them in pairs. Both do the same thing, but differently. UDP and TCP both format the data into packets, and with the IP they route it across the network. For TCP, if packets of data aren't delivered, it will request it again. These packets are slapped on with the IP address and MAC address. UDP doesn't provide this error checking, but it does the same thing, sending formatted data. So in short, TCP formats data by splitting it up in packets and gives the packet IP addresses to travel to and a number to identify each packet by. Almost there to the end, don't worry, we have the email protocols. SMTP is used for sending emails, stands for Simple Mail Transfer Protocol, so it says it in the name. POP3, it pops into the mail server, and when you want to view it, you have to download it. And the email will pop back out since no copies are stored on the server. So if you have to download it, someone could slip in malware, and since it pops back out, you can only view it on the device you opened it with. We call that no synchronization. IMAP4, the big daddy to POP3, it doesn't pop in and out because it's not the same name. So wild guess, it must keep a copy. Since it ain't downloaded, you need internet constantly to view it, however. FTP stands for File Transfer Protocol, wonder what that does. IP gives a unique address every time you connect to the network, key bit here is unique. 2 more sections and then you're done with me. We have TCP IP model, there's 4 layers in it: application, transport, internet and link. Way to remember them is a till or Matilda. So we have application, this is where the network applications such as web browsers and emails operate, so therefore HTTP, his twin, FTP and all those email protocols operate here. Transport, this sets up the communication between the 2 computers and agrees on settings like packet size. So transport sets up the transport, it doesn't actually transport data yet. TCP and UDP therefore are here. Internet, I stands for internet and I stands for IP, so the pair sits here. It addresses and packages data from transmission and then routes the packets across the network. You would have noticed I've said the same sort of thing for TCP, and that's because TCP and IP work together to do one task, practically, but TCP is not located here. Link layer, this is where network hardware is. You may hear NIC, network interface card. Just remember it's located here, and device drivers also sit here. Ethernet and Wi-Fi are therefore also going to be here. Finally, we have security, authentication, firewall, MAC address filtering and encryption. You can use FAME to remember it if you like some brain cells. Authentication verifies if it's actually the correct user through things like 2FA, email confirmations and biometrics like fingerprints. Encryption scrambles data around like spaghetti till you can't read it and you need a cipher to decrypt it. HTTPS uses encryption to keep your data safe. Firewall checks the incoming and outgoing traffic and allows data to pass through it if it follows a certain set of rules, like a border crossing in a nutshell. Firewall can be hardware or software. And finally, MAC address filtering. MAC address is the physical address of the computer. It can't change unlike IP. So it can blacklist or whitelist computers from the network, and since it's the physical address, they're blacklisted permanently. And that's everything you need to know. This took ages to make due to my terrible workflow. The vids after this will be so much better, so stick around, and thank you for watching.